Greetings everyone, my name is Associated, and in this video I'm going to be covering an educational software for mechanics of materials called MD Solids. This software was created by Professor Timothy A. Philpot from Missouri, USA. So without further ado, let's look at what this amazing software has to offer us. Okay, when we first launch the software up, we will be greeted with this user interface, and this software has been divided into three main categories, and they are the MD Solids help documents, MD Solids modules, and animated learning tools. In this first category, it is basically a tutorial on how you can input your numbers from the problems into the different modules that this software has to offer. For example, if you stumble across a Flexure problem, you can come into the Flexure model and read this, and after you read this you will be able to input your numbers and get the accurate results. This category is created so that we, the user, can use this software effectively. So on to our next category, which is the key player of this software. It is called the MD Solids modules. In this module, they are divided into 12 different modules, and each of the module deserves their own video. So in this video I'm going to be covering only the Flexure module, and let's get going. Now I'm going to click on the Flexure module, and we will be greeted with this user interface. And here is our problem. In this problem, it asks us to determine the maximum stress in the steel and in the wood. So in this case, we need to fill out the bending moment first, which is 850 pound-feet, and now we need to calculate the moment of inertia. In order to do that, we can click on this cross-section, and we will be taken to this page where there are many shapes, like all of them. You can play around and see which shape suits the problem the best. So in this case, I've done it many times before. It is the stiffened T-down shape. So as we can see, the bottom is on the bottom and this is on top, so we need to rotate it 180 degree, rotate, and now we need to enter the dimensions. For the width of the steel, it is 15 inches. We need to convert this to inch. The thickness is 0.5. The height of the wood is 3.5. The thickness of the steel is 0.5. And the overall height of everything is 4. In this problem, we need to think a bit logically. For example, if we have a wood this size and we want to convert it into steel, it will be smaller, since steel is much more denser than wood. Therefore, it can take a lot more load in a small sectional area. Let's assume this to be 1 inch for now. Let's click compute. This is the wrong shape, so we need to click compute again and again. So now we get the correct shape. Since this is a composite beam problems, we need to check this area, composite cross section. Material A. Material A is steel, so it's going to be A36 structural, has a value of 29,000 KSI. For the second material, it is the wood white spruce with a value of 1600 KSI. Let's assign those areas by clicking on the right mouse. On the right mouse, we click for the wood, the shape right here. For the left mouse, we click for the steel, which are these shapes. And now we can enter the original dimension, which is 15 for the wood. Now click compute, and there we have it, our moment of inertia. Here it is, 20.914 inches to the power 4, and the centroid top here is 2.86, and centroid from the bottom is 1.13. Since now we have the moment of inertia calculated, we can click back. We have our cross section, we have our bending moment. We can now find what it is asks us to find, which is the normal stress, and the maximum stress is 1395.497 psi. That is the maximum stress for the steel. And for the wood, it is basically this value right here, and 0.0552 times the maximum stress, which is 1395.497. It is equal to 77 psi. That is the maximum stress for the wood. So now we have reached our last but not least category of this software, which is called the animated learning tools. In this category. It is divided into 5 main sections spanning over 5 different lessons. This page is basically a bunch of mini quizzes that can prep you for an upcoming quiz or an exam, and or you can just come in here, have some fun, and strengthen your knowledge about strength of materials, centroids, and basically anything. So to conclude this, I hope you all learn a thing or two about this amazing software from this video, and I want to thank you all very much for watching. And I want to give a special thanks to Professor Numrat for teaching us and introducing us this amazing software. And thank you. Goodbye.